Today in this video, we will solve the question number 4 of LeetCode, which is median of two sorted arrays. So first we have to learn that basically what is the median, right? So, so if we have given an array, suppose an array is 1, 2, 3, 4. So in an odd length array, the median is basically the center element, right? The center element. And so basically, what is the median here? So median here is 3. So we have to return, if someone asks me that what is the median of this? So basically the center element, which is 3, is the median, right? Then second thing is if array is of even size, then who is the median? Then the median is the mid element. So basically, if we see here, the index is 0, 1, 2, 3. So 3 by 2. Right, 3 by 2, and which gives me 1. So if I want to check that who is the median, so if I run according to the index, it means that from 0 to 3, then the element that is present at the mid is 1, and the element that is present at mid plus 1 will be the second index, right? So basically, who is the median? So if the array size is even, then the median is the sum of mid and mid plus one element by 2. So if someone asks me that what is the median of this? So median is 3 plus 2 by 2, which gives me 2.5. So the median for the this array is, right, what? 2.5. Now, now we will learn about that what is actually the median. So basically, median is like a partition line. Okay, median is like a partition line. So median has some properties. So I will write it. So uh, i- median is something like a partition line. Something like a partition line which separates the array, which separate the array such that number of left element is equals to number of right element. Number of right element if array is of even size. Okay, and number of left element is one greater than number of right element, greater than number of right element if array is odd, array size is odd, right? And the second property is all the left element must be smaller than all the right element. Okay. So basically, what is this all line? So suppose, let's take an example. So basically, what is median? Median is basically a line. So let's write 1, 2, 3, 4. Now, what we will do, we will check, we have to find the median. So what I know is that median is basically a line. Okay. So the line must be either here or here or here or here or here. Okay. So that line, what it actually do? Right, what it actually do. So that line separates the array into two portions such that the number of left elements are equals to number of right elements. Okay, so if I place a line here, what I've seen here that, okay, the number of left element is equals to number of right elements, 2 and 2, right? And all the left elements must be smaller than all the right elements. So both the condition is satisfied. Okay, so if both the condition is satisfied, then how we can find the median? So to find the median, we will take the left element which is closer to the median line, and then we will take the right element which is closer to the median line and then divide it by 2 if the array size is even. Now let's talk about odd size array. So odd size array 1, 2, 3, 4 and 5, right? So so what is median? Basically median is a line. So we put some line. Now if I place line anywhere, what I know that the number of left element is never equals to number of right elements, because as the array size is odd, one extra element must be present. So where should I put that extra element? So I can put that extra element on left side array, like in this portion. Okay. And what is median then? So basically the element that is present on left side and which is greater from all the left element will be considered as to be a median. So what I've seen here is that, okay, on left side there are one extra element than right side. So basically this one is extra. And now this is basically the median line. So if this is median line, then whatever the element that is present before this median line will be my median. So if we see that what is actually median of this array, so median is basically 3. So hope so you understand that what is basically the median. Okay, so in an odd size array, the median is the center element, and in even size array, the median is the center element and center plus 1 or center minus 1. It's totally depend on what we take as an input. Like if we see that if we take from 0 to 3, then what is basically the median? It should be 1 and 2. But if we take from 0 to 4, like if we take the size to be n, then what we will do? We will take n by 2. So for n by 2, we will take mid plus 1 element. So that's why we have to took n minus 1 here. So it's totally depend on either we are iterating or either we are considering the index or will we consider the original length of an array. Okay, so let's solve this question. So in this question, it is given that there are two arrays. Okay, so we will learn the concept about one array, that how we can find in one array. Now what we know that if all the element that is present before median must be smaller than all the element that is present after median, then what we have to do? We have to short it. Then only it will be form some sequential order and the increasing order, right? So we have given two arrays. So how we can solve this? So what we do, we create another array and then store all the element inside it. So we will create another array. Okay. And then we use the loop in x nums1 and nums dot pushback, and then we place x in. And then there is nums2. And after that, what we will do, we will short it. So we will short it. Nums dot begin comma nums dot end. After sorted, we will check that what is the length of array. So how can we know the length of array? So basically this is size. Okay, this is basically the length of array. So if the length of the array is odd, then what we will do? So basically, okay, when the length is even, then what we will do? So when the length is even, we will take that whatever the mid element. Okay, so basically the mid is n by 2. Now, will we add nums of nums of n by 2 plus 1 or minus 1. So if we are considering according to the index, means minus 1 here, then we have to do plus 1 here, right? And if we consider the whole length, that what is the actual length, then we have to write minus 1 here, right? And what we will do, we will divide it by 2.0. That's it. And else what we will do, we will return whatever the element that is present on mid only. So nums of n by 2. A return 0.0. And basically we have to return it into double and the value are in integers. So we will multiply it 1.0. 1.0. So there is something wrong. Let me see that we will get 4 here, right? So why we will get 4 here? N by 2. Okay, that's why. I think so. I have to put the bracket here. Yeah, this is accepted. So this is accepted. But basically, this is the brute force approach. Because we are, if we see here that we use the space, which is n plus m, because what we do, we create a new array. Inside that, I will store both the array elements. After that, one thing also I will do is sorting. I will perform the sorting, right? So the sorting will take how much time? It will take n log n time. So what is this n basically? So it's the total size of array and how many elements are present there. So if we are creating a new array, what is the total size or what are the elements that is present? So it basically n plus m log n plus n, right? So basically the time complexity is n plus m log n plus m and the space complexity is n plus m. So this is the brute force approach. And in the question, it is given that what we have to do here is that we have to take only log m plus n time to complete this. So let's see how we actually solve it. So what happened is we have given the two arrays. Okay. So what is the one thing that I know? So one thing I know is that suppose if I have given two arrays, 1, 2, 3, and 4, 5, 6. Now, first, I want to know that how many elements are present on left side. So on array 1, it should be m elements, and on array 2, it should be n elements. Then half of the elements are present on left side, and half of the elements are present on right side. So if I want to know that how many elements are present on left side, I will divide it by 2. So I will get 3, right? Now, suppose if I increase one element, then again I want to know that how many elements are present. How many elements are present? So on m there are 4 and on n it should be 3. And if I divide it by 2, I will get 3.5. So will 3.5 elements are present in one array and 3.5 elements are present on another array? Is this possible? No. So what we also learned that if there is an odd size array, on left side there is one extra element. So how can we cover that one extra element? That on left side there will be 4 elements. So I will get 3.5. So if I add plus 1 into it, what I will get? So m is 4, n is 3, and plus 1 which is v 1. So it will convert it into 4 by 4, 4 plus 4, and we will get 4 elements on left side. So for odd elements, what we will do? We will do m plus n plus 1 by 2. So will this formula also work on even array? So what I know that on even, it should be 3 plus 3. And if I add 1, I want to know that how many elements are present on left side. So if I divide it by 2, what I will get? I will get 7 by 2. And as basically, if we see here that if I take the floor value, it will give me 3. So what I know that, okay, on an even size array, the total number of left cell element are equals to the total number of right element, and we get 3. So basically this formula works on both the array. That so how we will approach the question and how we will solve the question. So what we will do, we will put a cut anywhere. Okay, so basically if it is given that there are 3 elements in array 1 and suppose here 5, 6, 7 and 8. Okay, and let's take more elements, more elements. Now, what I will do, I will put the median cut on one array because I will not create another array. Okay, and we have to perform simulation on this one. So, okay, so what I will do, I will put cut on this array. Fine. After putting cut, I want to know that how many elements are present on left side. So there is a 9 size array. So 9 plus 1 by 2. It means that on left side there must be 5 elements must be present, right? So if I put cut here, how many elements are total present on left side? It will be 2. Okay, now how many elements I want more? I want 3 elements. So it means that I have to select it from another array. So I will take one element this, one element this, and one element this. Right. So I will put my cut 2 here. So it is a little bit intuitional that what we have to do. If this is a median cut, then what I know, because we are not combining the array, we are putting the cut on the array. And then after that, we will check if basically this is the median point. If this is the median point, then all the element that is present on left side must be smaller than all the element should be that will be present on right side, right? So how will we check that all the element that is present on left side is smaller than all the element that is present on right side? So what we know, if this is basically the median, okay, then will we have to compare it with all the element, or will we have to compare it with whatever the left maximum element? Because what I already know is that array is sorted. So it means that whatever the element that is present before must be smaller than this element. And if this is a median point, then whatever the left maximum element must be smaller than whatever the right minimum element, right? Right minimum element. So then only this will become a median line. Okay. So how will we check it? So one thing I know is that, okay, if I see only one array, then all the left element must be smaller than all the right element. So will we have to check on this array? No. So what we will do? We will take the left maximum from array 1 and right minimum from array 2. Because what happen is we have to think it visually that if I combine this both and if I short it, then there must be 2 somewhere present and 8 somewhere present. And if I see that 2 and 8 will come on same side, right, on same side. Suppose if 8 comes here. So what I will know? I will know that this will not be median because what I want that 2 must be smaller than 8. Then only whatever the line that I put is to be a median. Okay, because all the left element must be smaller than all the right element. Okay, so we will understand that what we actually have to do. Also, we have to understand here is that so, suppose if I put my cut here. Okay, I can put my cut anywhere. That from left, I will take. I can put in. I will put my cut anywhere. Like I will put here, here, or either here, here, or here. So I can put cut on 0 position also and on n position also. So I have to decide that on which array I will perform cut first. Will it be a array with maximum element or will it be the array with less amount of element? So let's see what is the problem if I pick up the array with larger amount of element. So what I know is that suppose let's take there is an array 1, 2, 3, 4, 5. And on another array, there must be 6 and 7. Now, what I know here is that if this is a 7 size array, then on left side, there must be 4 elements. Now, if I put my cut here, what I know that on left side, there is 5 element and on right side, there is no element. But how many elements I want on left side? I want total 4 elements. So I will select it from another array. So will second array has 4 elements? No. So as the second array has not 4 elements, so what we are observing here is that we have to put my cut on a smaller array. Like suppose if I put my cut on a smaller array, 1, 2, 3, 4, 5. Now if I put my cut here, what I know, I have to select 4 elements. Okay, on left side. So I can directly access 4 elements because it has larger number of elements. Now suppose if I put my cut here, I want total 4 elements on left side. So I will select 1 element from there and 3 elements from here. So it is possible. But if I take this situation that what 1, 2, 3, 4, 5, and if I put my cut here, I want that total number of element that is present on left side must be 4, but there is no four elements present on array 2. So that's why what we have understand that we have to put my cut on smaller array. So after putting the cut on a smaller array, what we will do, I will take the example 1, 2, 3, 4, basically which, and then 4, 5, 6, 7, right? So suppose we will put the cut here, then what I will know that on left side there is 1 element present, and so I have to take total 4 elements. So I will put my another cut here. And now after that I will check all the element that is present on left side must be smaller than all the element that is present on right side. So if I see here that the left maximum is 1 and here the right minimum is 7. So this condition satisfied. Now after that I will check that what is the left maximum here. So left maximum is 6 and right minimum is 2. So what I have seen that okay, let's start it again. So what I have understand here is, okay, so I have seen that, okay, left element is basically greater than a right element, right? So as the left element is greater than right element, so this is basically not the median. Okay, this is basically not the median line. So what I will do, I have to shift my median point. So will I shift on right side or will I shift my cut on left side? So let's shift on left side first. So if I shift it on left side, uh, then again I will check that what is the left maximum? It will be 2. And what is the right minimum? It will be 7. So this condition satisfied. Now after that, I will check what is the left maximum. Okay. So basically, if I shift a point here, then on this side, this will be shift here, right? So I will see that what is basically the left maximum now. So left maximum is again 5. And what is the right minimum? So basically, the right minimum is 3. So it means that shifting my point on left side will will solve my problem, maybe. Okay. So will solve my problem, maybe. So again, what I will do, because what happened is previously the gap is what? Previously the gap is 6 and 3, and now the gap is 5 and 3. So it means that shifting in this side will work somehow. So after that, I will shift my median here. So if I shift my median here, what I've seen here is, okay, from on left side, I have to take 4 elements. So I will take 3 elements, and now I am left with 1 element, so I will take here. So what I know that whatever the maximum element that is present on left side must be smaller than whatever the element that is present on right side. So 3 is smaller than 5. So this condition satisfied. Now after that, I will check that there is no element. So what we will consider as a boundary? So we will consider the boundary as int maximum. Okay. So after that, I will check will the left maximum element is smaller than right minimum? Yeah. So basically 4 is smaller than int max. So we will decided that yeah, I will find the median. So we are actually putting two cuts, right? Two cuts. So if we are putting two cuts, then which will be median? Will it be 3 or will it be 4? So how can we judge that? So basically, we have two cuts. One is 3, one is 4. Now we have to think about it. Like what we have to think? We have to think that if both elements are present on a sorted array, then which one comes closer to median? Will it be 4 or 3 because this is basically the odd size array. So we have to put median here, right? So on left side there is one more element. So which one is closer to median line? So basically 4. So what we are understand here is that okay, if I found that all the left elements are smaller than all the right element, then the median is maximum of left max 1 and left max 2. So left max 1 is 3, left max 2 is 4. And from that, who is maximum? So maximum is basically 4. So the median is this. Now, if suppose if the array is of even size, so then what we will do? Uh, 2 and then 6. Now, if I found that array is of even size, then what is median? Median is basically whatever the element that is present on the left side of the median line and whatever the element that is present on the right side of the median line. And then we will divide it by 2, right? So how we will check that what we have to take as a median from left and what is the right element. Okay, so if we put it in sorted order, it looks something like this: 2, 3, 5, 6, and basically this is the median line, right? This is the median line because both the element come on right side and both the element come on left side, and this is basically the median line. So what we are observing here that from left maximum 1 and left maximum 2, which one is closer? The maximum one is closer. And from right minimum 1 and right minimum 2, which one is closer? The minimum one is closer to that line. Fine. So it means that when the array size is of even, then what we will take? We will take whatever the maximum from left max 1 and left max 2, and whatever the minimum from right min 1 and right min 2. And then we will, after taking that both the element, we will divide it by 2 to get the median. So basically, what we are doing here is we are shifting our cuts, and according to that cut, we are judging that where will I have to do something or not, or will I have to consider that to be a median or not. So mm, what we will do, let's take something. So let's try to solve this question and then we will analyze that what is the space and time complexity of this. So first thing what I know is that I have to check that which array has a smaller size. So we'll find this array size nums1 dot size and then nums2 dot size. And after that we will check if n is greater than m. So basically we will consider the smaller size array to be a nums1. So if n1 is greater than m, so n is greater than m, what we will do? We will again call the function. So basically, why we are calling this function? So we are calling this function. So if suppose if nums1 is smaller than nums2, then there is no problem. But if nums1 is greater, what we will do? We will pass nums1 element into nums2 and nums2 element into nums1. So how we will do that? We will call that function and just change the variables. Okay, so we will make nums2 as the first array and nums1 is to be my second array. And we will return it. Return it. Fine. So after that, what we will do? We will apply the binary search here. So binary search is used for cutting. So I can put my cut anywhere like on 0 also or n also. Right. After that, we will calculate at how many total elements I have. So it will be basically n plus m plus 1. Right. And now we will apply the binary search here. So while start is less than equals to n. And then we will find that whatever the mid is. So mid is basically start plus and minus start and minus start by 2. And what is basically this mid? So basically this mid will tell me that what is the cut one, where we are placing that cut. So after placing our cut, what this cut will tell me that how many total number of element that I actually take on left side. Okay, so again I have to take cut 2. So what cut 2 will decide? Cut 2 will decide that how many elements that I want more. Okay, so I have selected cut 1 elements, and now I have to take how many elements? I have to take total by 2 elements on left side. Okay, total by 2 element on left side. I already take cut 1 element. So how many elements I am left with? So I will subtract cut 1 only. So I will get that that much element I have taken from cut 2 also. So after that, what I will do, I will check that what is the left maximum. So first I will check according to cut 1. So if I see that, okay, if I put my cut 1 is equals to 0, it means that I have provided my cut uh, here. So if I put my cut here, then what is the left maximum? So left maximum is basically there is no element. So I will consider the minimum value of integer to be my left maximum. Fine. So what I will do, I will mark it as int max. And otherwise, what I will do, I will take the left maximum is to be a nums1 of cut minus 1. Cut 1 minus 1. So basically, whatever the element that is present or before that cut will be my left maximum, right? So and then we will do same for left 2 also. So for left 2, we will check that if cut 2 is equals to 0, we will take int me, and otherwise nums2 cut 2. Okay, and then we will do this same thing for right also. So if suppose if I put my cut here, like if I am selecting that how if I want to take that what is the right min. So suppose if I put my cut here, so okay, 1, 2, 3. If I put my cut here, so then what is the right minimum element from left array 1? So the right minimum should be the maximum element that is present according to integer. So it should be int max, right? Because there is no element, so I have to take some boundary. So that's why. So if cut 1 is equals to n, then I will take whatever the max, and then otherwise whatever the element that is present on the cut, right? On the cut. So basically, why we are taking that cut 1? So basically, cut 1 will, so suppose if there are two elements, I will put cut here. So with this cut, what it will represent? It will represent basically this index. Okay, this index. So if it represents this index, so this is basically the right minimum element. And that's why if I put my cut here and if this index is considered, then that's why I will take the left maximum to be a cut minus 1 element. So cut minus 1 element should be 2, right? So that's why. Cut 1 and I have to put cut 2 here and it should be M, right? M and max. And it should be R2. R2. And after that, what I will do, I will check that, okay, if L1 is less than equals to R, because why R2? Because on if I check one array, all the elements are sorted, then all the right element must be greater than all the left element. So there is no way that I can compare this because I already always get that okay, all the right element are greater than the left element. So that's why we have to check it with another array, a right minimum. So left one is less than right minimum. Left max is basically lesser than right min 2, and left 2 is lesser than right minimum. So if this is, then we will check that what is the length. So what is the length? M plus n. M plus n by 2, right? So after checking this, if this is basically even, so if basically this is even, what we will do? We will take the maximum from left max 1 and left max 2. So maximum from left max 1 and left max 2, and then we will add the minimum from right min 1 and right min 2. And then we will divide it by 2.0, right? And else what we will do? Else what we will do? That basically the array size is odd. So if array size is odd, so whatever the maximum from left one com- comma left 2 will be considered, and I will multiply it to 1.0. Now, if the elements are not according to our expectation, like this is not the cut, and this cut will not represent the median. So when we have to move in either of the direction, so let's take 1, 2, 1, 2, 5, and 4, 3, 6, 7. Okay, so 4, 3, 6, 7. So suppose if I put my cut here, so another cut I will put here. So what I will see that okay, 2 is basically smaller than 6, it's fine, and 3 is basically okay. I have done something wrong. Wait, so yeah, I have to take 1, 2, 3 here, and 5, 6, 7, 8. So suppose if I put my first cut here, okay, first cut here, and so it means that I have to take total 4 elements on left side. So I will see that okay, whatever the maximum element that is present on left side should be smaller than whatever the element that is present on right side. And if this is not, I have to shift my cut. So I have to shift my cut on right side, right? So what I've seen here is that if the left max 2 element is greater than right min 1, then I have to shift my cut on the right side. Okay, so if left L2 is basically greater than R1, then I will move start is equals to cut plus 1, cut plus 1. And otherwise, I will move my pointer to cut minus 1. So if else if L2 is greater than R1, what I will do? I will move my cut. So I will move start is equals to cut plus, so basically cut 1 plus 1. And else what I will do? End is equals to cut 2. No, cut 2 not. It's cut 1 minus 1. So basically this is it. And we will return here what? We will return 0 0.0. So let's see if this will work or not. Oh, we get overflow. So basically we have to take cut 2 here. And we have to take array 2. Yeah, this is accepted. So it is accepted. And if you see the complexity here, we are not using any extra space, and we can only traverse on 2 arrays, M and N. So basically also we are applying the binary search that on one section it will eliminate half of the array. So the total time complexity will be log of M plus N here. So basically this is the optimal approach. So hope you understand, guys. Thank you. Thank you so much.